Hello everyone, my name is Lian from Fumiya Corporation, Japan. So today I'll be presenting the development of a low-code-based program planning interface systems for coordinated works of multiple construction machines. So here's the agendas. I would like to first talk about the background of our research and what exactly is multi-robot coordination and as well as the objectives of our research. And later we'll talk about the system architectures followed by the prototype development. And based on the development results, we'll have a brief discussion about the results and finally the conclusion as well as for the future works. Okay, so here's a very brief intro, background of our research. So the construction industries has been facing very severe labor shortages due to the aged populations and difficulty in attracting younger people, which is especially the case in Japan. And in light of these situations, the Japanese government has initiated the I construction 2.0 to leverage the ICT technologies to achieve at least 30% increase in productivities by 2040. And one approach to achieve such goals will be to use the automated and autonomous construction machines. And there have been certain progress within that kind of areas, but most of the automated construction machines is for individual tasks at the moment. So the excavators is mainly for its own excavation jobs. The dump truck is only for its own transportation jobs. So they have been very they are very separated, and we're hoping to have a more coordinated and collaborative frameworks that actually can coordinate the operations of multiple machines. So as of now, the conventional approach for multi-robot coordinations is mainly is rather manual. So the engineers will actually see the actual construction status of each machines and to decide manually if they need to move on to the next stage. So very examples for when the excavator started doing the digging jobs and dig, lift, rotate, and then dump the soil into the dump trucks, and the engineers can just manually to check if it needs to stop the excavation process and then send signals to the dump trucks to transport the soil to the dump site. So it's very has a very high level of human interventions. And one of the approach that actually be done to get rid of this kind of human intervention is to, of course, we can do the codings do the codings, but it's very difficult for civil engineers to actually do that kind of hard coding. So therefore, we need some more intuitive ways to actually can replace the manual interventions for the multi-robot coordination. So therefore, the objectives of this study is actually to first develop a very user-friendly interface for the civil engineers to configure the construction flows, and the system itself should be easy to use by the civil engineers because even with no programming skills, they can still easy to configure the flows. And also, it should have a data visualization capabilities because there are always real-time data coming from the site, and the office needs to constantly monitor the status of the different construction machines. And last but not least, the platform should be open and collaborative for all engineers to collaborate together. So based on all these, we have developed planning interface systems, which I will introduce later. So at the top, we have construction planning systems. It defines the task, the robot selection, and operation instructions. And then we translate all these kind of instruction requirements into some kind of operational logics, which can be easily configured in the planning interface systems. And at the end, we have our edge robots, the different kinds of construction machines. They are doing the works as well as to constantly acquire the data from the sites, and it sends the data back to our planning interface systems, and which will constantly analyze the data and to check if it has meet a certain triggering conditions. And once it is, then we'll send operational commands back to the construction machines. So based on the system architectures, we have developed a prototypes. And for the prototype, the platform we have chose is the Node.led platform. And the reason why we chose it because it has a browser-based features, and it has easy access for developers to collaborate, and it's also very easy to deploy the programs with just only one click. And its visual programming features make it easier to configure very complex operational logics. and also it has a certain compatibilities with the operating robot operating system ROS, which is the system, which is the protocols we have used in our construction site for the construction robots. And there are certain open source packages that help us to achieve these kind of compatibilities. And the one we used is the EduArt Robotics, and it's developed based on the ROS client node.js packages. And it just makes it so easy to do the topic publish subscribes, as well as to execute the surveys and actions. And for the scenario selection, we have considered the earthwork projects because it's very repetitive works, but it's also very predictable. And it also requires high level of construction automations. And it's normally within a very open space with very minimum of external interference. And it makes it a perfect controlled environment for testings. So this is the basic workflow of the earthwork projects, and the trigger conditions is used to actually to coordinate between different construction machines. So our planning interface system needs to constantly monitor if the certain conditions has been met, and once it's met, then it sends signals to the next work. So, and this is the scope of our prototype development. We have now break it down into 4 tasks. And so this is the scenario bit for individual tasks, and we have actually configured this kind of workflows based on visually within our planning interface systems. So as for the scenarios we have considered, we need to actually configure the operation logics behind the workflows in our planning interface systems. As you can see, this is the examples for the logics that we have configured. And under the hood is just basically some very basic ROS topic publish, subscribe, service call, and execute action. That kind of works that we have done here. So we wouldn't go into the details as for what is exactly done, but as you can see from here. And also as I have said, so data visualization is also very important in order to monitor the real-time data from the site. So, and our planning interface system is also capable of developing very simple dashboards. And as you can see from the left-hand side, is mainly just for the data acquisition process and data and processing nodes. And on the right-hand side is the node for making dashboard elements. And just by simply configure the flow, so that we can actually produce a very easy to read dashboard. As you can see, now we can monitor. So this is just examples. We can now monitor the total distance traveled by the machines, the linear velocities, as well as the movement trajectory of the construction machines. So here's the simulation results. And the simulation environment is developed in the Gazebo, the open source simulation environment. And as you can see here, this is the operational logics that we have configured in the planning interface systems. And now it has to start digging. Once it's loaded to the construction machines, then they will receive the triggers and move to a different place to dump the soils. And it has reached the positions, and now it will dump the soils. And once it's done, it will continue to move until it reaches its initial position for the next run of work. So just a very simple demonstrations. So finally, the conclusions. So first, we have developed a local planning interface system based on Node-RED, and to integrate construction planning systems with the coordinated operations of multiple robots. And the planning interface system offers a very intuitive interface for civil engineers, simplifies the operational logic configuration, as well as it's compatible with the ROS middlewares for easy integration with the existing robotic systems inside in our Shimizu operations. And there's a prototype has been successfully demonstrated. The coordination works between between the excavators as well as the dump trucks, and showcasing the capabilities to actually unify the isolated automation tasks into very collaborative construction frameworks. And it also has the capabilities for data visualizations. Okay, yeah, thank you very much for your attention. Thank you very much for your time and attention.